Welcome to Organic Chemistry. Today we're going to be discussing how to draw alkanes, alkenes, and alkynes. The previous videos we discussed the basics of organic chemistry, and we discussed the basics of naming alkanes, alkenes, and alkynes. In my preference, I think this is easier than naming, because this is a bunch of puzzle pieces that we're drawing. So let's get drawn. So our first example is the two-methylhexane. So I actually work backwards, and I literally go by each of these base words. So ane. I know everything I have to draw is an ane that means a single bond. Next, what is our first set of carbons deal with? It's hex, that's 6. So we'll do 6 carbons. There's 6 carbons. Here are the single bonds. So we're already done with hexane. Then we've got 2-methyl. So I'm just going to go left to right. We're going to add our methyl group. So this is going to be C. And we know methyl is CH3 for the group. And it's at number 2. So it's going to be 2-methylhexane. And then from now on, you just have to add your carbons, making sure each one has 4 bonds to it. So making sure you add enough hydrogens to each one. So this is the drawing out. Almost forgot one. This is the drawing out of 2-methylhexane. Single bond, 2-methyl, 6 carbons, and all single bonds. So number 2, it's a little bit bigger. So this is considered 3-ethyl, 3-methyl, 1-hexene. So I'll start in the back again. It's an ene, so there's at least 1 double bond. Where's the double bond going to be? It's going to be at carbon number 1. And how many carbons are there? Again, there are hex, so there are 6 of them. So 1, 2, 3, 4, 5, 6. Double bond, once again, is at the first one. So there's our double bond. There's only 1. Everything else gets a single bond. Then we work on our groups. We have a methyl group, and it's at 3. So we'll start, go 1, 2, 3. We'll add our CH3, which is methyl. Now we've got to worry about the other group, which is an ethyl. And we have meth, and this goes at 3. So this is going to be 1 more carbon, so it's going to be CH2, CH3. So we've got our 3-ethyl, we have our 3-methyl, we have our 1-hexene. And then we just add the carbons on here. Add the hydrogens, I apologize. So that's our 3-ethyl, 3-methyl, 1-hexene. Example number 3. A little bit bigger, but it doesn't matter how big it is because we're just going to take it piece by piece. 6,6-diethyl, 5-methyl, 5-propyl, 3-decyne. So let's start all the way at the end again. We have ine. It means we have a bond, a single triple bond. So 1 triple bond. The 1 triple bond is going to be at carbon number 3. And how many carbons are there going to be? There's dec, referring to dec as in 10. So we have our 10 C's. 10 C's. Add in our triple bond, which is that's carbon 1, carbon 2. That is our triple bond. So carbon 3 has a triple bond. There's only 1 of them. Everything else get single bonds. Working our way up. 5 propyl. So once again, think about the prefixes. Meth, eth, prop. So this is going to be 3 C's. So we go to the 5th carbon. 1, 2, 3, 4, 5. We'll go up on this. And since this is, it's going to be CH2, CH2, CH3. This is our propyl. And that goes at 5 propyl. 5-methyl. So the same carbon, we're doing a CH3. So just a methyl group. Keep working up. We have ethyl. We have 2 of them, and they're at 6 and 6. So it's going to be right next to these. There's going to be one on the top. So this is ethyl CH2, CH3. This is CH2, CH3. 2 ethyls on number 6. And we've got 1M5 for methyl, 1M5 for propyl. 3 is our triple bond, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. So now we have 6,6 diethyl, 5 methyl, 5 propyl, 3 decon. And when we add, the last part of this is add all the carbon, all the hydrogens. Now this gets tedious because now we're adding like 20-some hydrogens on here. So after this, I'm going to show you how to quicken this drawing up. So these are the expanded